Hello ladies, gentlemen and anything in between. Welcome to another video of Maths with Hamblin with your beautiful host, Hamblin.
And today, my boys, we're going to build on what we did last episode where we derived the quadratic formula, and we're going to learn how to use it. We're going to learn about the discriminant, which is to do with how many roots a quadratic has, and we're just going to have some practice using the quadratic formula. So let's go, shall we, boys? Okay, so my boys, first, well, some quadratics don't have it. Okay, so as I said before, the discriminant of a quadratic is all about how many roots it has, how many solutions a quadratic equation has. Because some quadratics have no solutions, some have exactly one, and some have beautiful two solutions. And how we can tell exactly how many solutions they have just by looking at the quadratic is really nice, and we can see it in the quadratic formula here. Now, pay your attention to this bit of the quadratic formula, the square root of b squared minus 4ac. Now, let's think about what happens. What if this thing turns out to be positive inside the square root here? Well, if this thing is positive, then taking the square root of it, no problems, and we'll get a plus or minus here, and we'll get two separate answers. So if the discriminant here is positive, then we'll get two answers. So I'm going to write that down, b squared minus 4ac. If that is greater than 0, well then you can take the square root of it sensibly and get two separate solutions. Then that implies we get two solutions. We get two roots for our quadratic. Now, what if the special case where b squared minus 4ac is exactly equal to 0? Well, when we take the square root of 0, we're going to get plus or minus 0, which it's just 0. There's not a plus or minus 0, it's just 0. So you'll only get one exact solution when b squared minus 4ac is equal to 0, because the square root of 0 is just 0. So if this exactly equals 0, we'll get one solution. Now, the most interesting thing is, what if b squared minus 4ac happens to come out negative for a particular quadratic? Well, if you can't take the square root of a negative number when you think about it, it's one of those things that, like dividing by 0, breaks maths. Because if you try and think about it, what's the square root of negative 2, for example? Well, it can't be a positive number, because positive times positive, you get positive. And it can't be a negative either, because if you do negative times negative, you get a positive as well. So you can't take the square roots of negative numbers, and that is something very important. So if this b squared minus 4ac is negative, well then the quadratic formula just kind of breaks, and there'll be no solutions whatsoever. I hope that can make sense to you guys. So if b squared minus 4ac turns out to be less than 0, then we'll get no solutions to the quadratic. So that is how we can just look at a quadratic equation and know how many solutions it will have. So all you do is you look at the values of b, a, and c, and you chuck them into this, which is called the discriminant, and you check if it satisfies one of these three conditions. You can see exactly how many solutions it has. So that's pretty bueno, my boys. Now let's get into a first problem. Okay, so my boys, this first problem here is we've got two functions here, and we're going to ask to solve f of x equals g of x. So we're going to solve what value of x, when you chuck into f and chuck into g, you get the same number. And we're also going to find out exactly how many solutions it has using the discriminant before we solve it. So if we set this up, well, we want x squared minus 2x minus 15 to equal 2x minus 5. Okay. Now, recall, the quadratic formula only works when you've got the quadratic equal to 0. So, by continuation, the discriminant only makes sense if you've got the quadratic equal to 0. So we want to find some quadratic equal to 0 here. So if we subtract 2x on both sides and then add 5, we'll get this lovely quadratic equation. So our special number x that satisfies this equation also must satisfy this quadratic right here. And we can check, well, how many solutions are there for x that are possible for f of x and g of x to equal each other here. And we can check that using the discriminant first of all. So we're going to take b squared, so we've got minus 4 squared, and then we subtract 4 times a, which is 1, and then times negative 10. That is 16. This minus will become a plus, and we'll get plus 40. Now, the discriminant is positive, which, if you recall, means that we can sensibly take the square root of it and get a positive and negative answer. So this quadratic has two solutions. So there is two different values of x, such that this equation is true. And then we can just figure that out using the quadratic formula. So we can plug our values in. We get x equals negative b, so negative 4 is 4, plus minus root. Negative 4 squared is 16, then minus 4 times 1 times minus 10, and all over 2, because 2 times 1 is 2. And then we can simplify that to 4 plus or minus root. Okay, well, 16 minus 4 times minus 10, that's 16 plus 40, which is 56 over 2. So our two solutions are 4 plus root 56 over 2, and I'm going to put it down here, 4 minus root 56 over 2. So those are the two exact solutions for x which satisfy that equation. So boom, let's go on to the next one, boys. Okay, so my dear viewer, this looks pretty scary. We've got a quadratic, not a quadratic actually, just a polynomial function here that's equal to a product of two quadratic factors. And that's pretty hard, and we want to solve f of x equals 0. Okay, so let's write that problem down just to be easy. So we get a nice algebraic handle on things. Oh, and that equals 0. Now, if you recall, just using the same logic we do with factorization, we've got a product of two things and they equal 0. So either this thing equals 0 or this thing equals 0. So we can say, okay, well, either x squared minus 7x minus 11 equals 0, or x squared minus 6x plus 9 equals 0. And first of all, let's find out exactly how many solutions there are to this and this using the discriminant, and by proxy figuring out exactly how many solutions there are there to f of x equals 0, so we're finding how many roots f of x has. And we could do that using the discriminant on each of these quadratics here. The discriminant here is negative 7 squared minus 4 times 1 times negative 11. That is 49, those two minuses will cancel out, so this will be a positive number, so we'll get two solutions from this quadratic. And this quadratic, okay, well that's negative 6 squared minus 4 times 9, that's 36 minus 36, that equals 0. Okay, so the discriminant of this quadratic is exactly equal to 0, which means there's exactly only one solution for this quadratic. So from this bracket, we can get two solutions. From this bracket, we get one solution. Therefore, the original function here has exactly 3 roots. Sorry, we only get one solution from this. I think I misspoke, sorry. So we get 3 solutions for that quadratic, for that polynomial function there. 3 nice roots. And let's find out what they are, shall we? So let's use the quadratic formula on this one first. So we're going to get x equals 7 plus minus root. Negative 7 squared is 49. Minus 4 times 1 times minus 11. All over 2. Rightio, and that equals 7 plus minus root 49. These two minuses become a plus. 49 plus 44 is 93. So, right, those are our first two solutions for f of x equals 0. And then we can use the quadratic formula on this bad boy right here, which is going to take up some space, that's fine. So for the second one, sorry, I'm kind of running out of space, equals 6 plus minus root of 36, because negative 6 squared is 6, minus 4 times, well, that's 4 times 1 times 9. And as we recall, this exactly equals 0. So we get x equals, well, 6 plus 0 is 0, over 2 is 3. So boom, there we go, my boys. Those are the two solutions, the 3 solutions for that polynomial function up here, this crazy polynomial function up here. There you go, pretty nice. Okay, so now my boys, we're going to try and do this one. We're going to find out exactly how many solutions this has. And we're not going to try and solve it, we're just going to find out exactly how many real solutions there are to this equation. And it's not obvious at first how we might use this using the discriminant, but actually this is a quadratic equation in disguise. And you might think, okay, how can we turn that into a nice quadratic? Well, the main problem here is we've got these nasty things on the denominator, but that's fine because we can get rid of them by just multiplying by the denominator. So if we multiply by x plus 1 on both sides, we get 3 equals x plus 4 over x minus 1 times x plus 1. And then we can just multiply by x minus 1. And then we get 3 times x minus 1 equals x plus 4 times x plus 1. And now, my boys, look at that. That is a quadratic equation. When we factor this out, we'll get quadratic, and then we can subtract off this linear bit here, and we're still left with a quadratic. So then we can see, using the discriminant, exactly how many solutions we're going to get for this equation. So expanding this is 3x minus 3, and that equals, okay, well, x squared plus x plus 4x plus 4. So that equals x squared plus 5x plus 4. Right, okay. And now we can subtract off these two on both sides. We get 0 equals, well, we subtract 3x, we get x squared plus 2x. And then we can add 3, we get plus 7. Okay, and now we've got a quadratic equal to 0, so we can use the discriminant to check how many real values, how many solutions for x exist. So let's do that. The discriminant, b squared, that's 4 minus 4 times 1 times 7. And oh dear, I think that's pretty obvious, to me at least, that this is going to be a negative number. So in fact, we're not going to get any solutions to this equation. So this equation up here has exactly 0 real solutions, which is pretty crazy to me. I mean, you can put in any number for x you like, and you'll never ever find one that satisfies that equation. So that's pretty crazy. So, in conclusion, my boys, the discriminant is a little part of the quadratic formula you can use to check whether a quadratic has real solutions or not, and exactly how many they are. If it's positive, then you get a sensible square root, you get plus or a minus, which is 2 solutions. If it's exactly 0, then you get just the square root of 0, which is 0, and you only get 1 solution. And if it's negative, then you're taking the square root of a negative number, which breaks maths, and no solutions for you. So that's it, my boys. That's the discriminant and using the quadratic formula. I hope you found this video helpful. If you do, please let me know in the comments below. Thanks for watching.